This is a video update for the ion lifter power supply. This time, instead of using a voltage multiplier and a ZVS or a feedback coil, I'm using a 555 timer. All the parts for the 555 timer can easily be obtained. I bought them all from Micro Center. Even the MOSFETs you can get from Micro Center. This is running off of a 11.1 volt battery, the same one I run with my ZVS. The only difference is the capacitors for this flyback. I was using different types of capacitors, but this one actually gave me the best results, especially when I combined both of them in parallel. This came from my ZVS driver. One of the MOSFETs failed, so I disassembled it. So let's see the type of arcs we get out of this with a flyback with 555. Connect the battery, and let's see. So that right there is about 25, maybe to 30,000 volts right there. It's not bad. The MOSFET, still cold, no problems. So what I'm going to do now is disconnect this flyback, and I'm going to use the other flyback. This one is the AC flyback. I'm going to use this one. This is the DC flyback, and we'll see the type of results we get out of that one. Okay, here's the flyback driver DC that we're using now with the 555 timer. I have some other capacitors, that I notice makes a difference. The capacitor I was using for this one, it's not going to come into focus, but it came out of a power supply unit. I was able to look it up. It says it was supposed to be 0033 or something. I don't know. But we plug it in. Plug the battery in. We turn it on. Not bad, but it's noisy. You can hear it. So now I have a 0.0022 capacitor. I'm going to plug that one in now. See the results we get out of this one now. Not bad. Okay. Now I have a capacitor that is a 0.001 UF. So now we're going to plug that one in. Plug in the power supply. And this one, the arcs are quiet. Look at that. Quiet arcs. Let's try adjusting the frequency. I may have to use two hands for this one. Just a duty cycle. not bad. And the heatsink, it's warm. It's got some heat to it, but it's not a big heatsink. But you can see now, using a different capacitor will change the frequency and it'll up it. So now it's a lot more quieter compared to running with this one here. Pretty much, you know, like I said, everything you can get at Micro Center. You know, the flyback, like I said, was from Amazon. The capacitors came off of that ZVS driver. Everything for the 555 is from Micro Center. Even the capacitors, they came in a box. This one here. And the frequency you just heard that was quiet was bag number 7. The other bag before that was bag 22. But this still needs some tweaking, because I've noticed that, let me unplug the battery, on the coils, when I put a diode, a flyback diode, reverse breakdown diode, it doesn't work. I don't know. I have different types of diodes, all different ratings. And I tried using one of my diodes out of the voltage multipliers. That actually worked. It actually kicked up the power, the output. The only problem was that diode started getting hot and it was actually starting to smoke. You know, so I realized, okay, I can't use that diode right there. But I did measure the amperage coming out of these flybacks the other day, and I was getting about 8 amps, which is really good. So 12 volts at 8 amps, that's 96 watts of power. Now, everybody knows that the gates on MOSFETs needs pretty much 10 volts to turn on. And with a 555, whatever your input voltage is, the output at pin 3 is supposed to be 2 volts less. So if I'm running at fully charged, this is 12 volts. That means the output pin should be 10 volts. 10 volts is more than enough to turn on the gate completely. I measured with my voltmeter at pin 3. I've only got about 7.5 volts. So I've lost about 5 volts, 4 or 5 volts. That's a big voltage drop, which I don't know why. I was reading online saying that maybe the time high is not high enough because, you know, it is oscillating on pin 3. So the duty cycle, so that could be a reason why. But as for the flyback, yeah, let's see. I can unplug this. Okay. It's just a flyback driver out of pin 3. I calculated it. It's a 270 ohm resistor to the gate with a reversed 4007 diode. The pull down resistor is a 10K. And they also say to have a snubber circuit to protect the MOSFET is a capacitor in series with a resistor. And it works just fine. Now, the MOSFETs at Micro Center, they have the 2389, but for some odd reason, this one, it just smoked and blew out. I guess because the voltage drain to source isn't that high. They always say get a MOSFET with a very high voltage drain to source, but the RDS, the resistance drain source, has to be low. So this is actually an IRF 520. This is actually really good, the arcs you just saw. I also have an IRF 540. So this little thing was handling 8 amps. And look, I'm holding it. It's not really hot. I'm fine. You know, because I had bought 5 of these. I bought 5 of a whole bunch of other MOSFETs. And they were exploding because I just didn't read the data sheets because I didn't understand them. So I had to watch several videos and just read online how to use MOSFETs. So now I got an understanding of how to run a MOSFET. So, like I said, this is just to get it running. I'm still going to have to work on other things. like how to really, if I can really fine tune the frequency. 555s can only handle 4 to 15 volts. So even if I was to connect 2 batteries in series, you know, I'll have 24 volts. The 555 can't handle 24 volts. So the next thing would be to either use the output of the 555 to trigger a transistor, which triggers the MOSFET, or to use an optocoupler. I found out that the most expensive MOSFETs I purchased, they were like 900 volts drain to source, 30 volts gate to source. The problem was that the on resistance was 1.2 ohms. That's a lot. This RDS on this is like 0.05 or something. You know, if you look at the data sheet right here on the back of the NTE, you see the voltage drain to source is 60 volts. They always say get a MOSFET that's, you know, 5 to 10 times more than the volts you're applying. I'm applying 12 volts. This is 60 volts. That's 5, not 10 times more. Okay. Maximum gate to source is 30 volts. The voltage gate to source off, 4 volts, meaning that this needs a minimum of 4 volts for the MOSFET to turn completely off. Also, the CISS is basically the capacitor, because the gate and the source is a capacitor. That's why it needs voltage, not current. Maximum power dissipation, 125 watts. Like I said, with this 8 amps, 12 volts, I'm running at 96 watts. So I'm running pretty good. The current is 35 amps max. Well, as you see, I had 8 amps max when I was running it, because I measured it already. And see, RDS on 0.045 ohms. That's what you're looking for. That's the key. You want a MOSFET that has a very low RDS on and a very high voltage drain source. That's what you want. That's why this MOSFET failed, because the abuse it's taking, because the voltage is spiking from the inductor, is going back into it. So I also got to build a snubber clamp for the inductor. They say use the capacitor with a resistor and diode. So I got to do more research on the diode, but I'll figure it out. But if anybody has any idea as to why, maybe possibly my volts was going from 12 volts in and 7 volts out instead of the 2 volts. Like I said, could be the duty cycle. I don't know. I may have to retest it, because I think that if I can get 10 volts to fully saturate that gate, then it's fully open and I can get more volts and more currents going into this driver and have a bigger output, because I'm going to eventually combine 24 volts. Because if this is outputting about maybe 30,000 volts, 2 batteries in series, I might be able to get 70,000 volts. And they say flyback drivers usually can handle about 70,000 volts before internal breakdown. But yeah, well, that's it for now. Okay.